Don't forget to follow us on Telegram at Hobby Meet Vietnam to chat with the team directly from Hobby Pro. And the next presentation, I would like to introduce Mr. Roy Lee, the founder and CEO of Ruff to share his talk about the best both worlds, blockchain and ITO. Please give a big applause to welcome Mr. Roy Lee.
Okay. Unlike the other speakers, my speech is going to be pretty much tech-based. So from my previous experience, I would advise that if you feel it's really hard to understand, do not try your best to understand it, because that will make you sleepy. So just relax, okay? I'm going to start my speech with the story. Shit, that's not my slide. Okay, good. So I'm going to show you 3 words. That's not going to be too much wording, because it's very tech-based, and I don't want you to look at those fancy words. But still, I have to show you 3 words. How many of you actually know the meaning of those 3 words? Raise your hand. Yeah, you know that. I know you know that. Yeah, you look like a developer. Yeah, right? Looks like there are not so many developers. Those 3 words are for developers. If you ever had a chance to write your smart contract, your first smart contract, which can be written in 30 minutes on Ethereum, on the easiest network on this planet, you're going to face those 3 words. The first one, Robston, and the second one is Coven, and the third one is called Rinkeby. Those 3 words are the 3 names of the public test network for Ethereum. Once you get a chance to deploy your first smart contract, you may deploy on any of those 3 public test networks. The reason why I'm going to tell you the story is that I'm going to tell you the story behind it. It's about how the story about the POW and the proof of authority you might not heard of, how the proof of authority works, and how the non-economy-driven public test network evolved from its early stage to what it's like right now. Robston is not actually the first test network for Ethereum. The first network was called Morden, and it was reborn with Robston because it was facing the synchronization issues and also the consensus issues between 2 major client-side software called Parity and Gas. Robston ran smoothly for a couple of months on a relatively low computing power. You know, the test network does not have enough computing power, so there's absolutely no incentive for the miners. So the miners are just like volunteers. The computing power is very limited. Then somebody actually attacked. Malicious actors happened on this public test network because there's no cost for those attacks. The computing power is so low, and there's no cash incentive. And then Coven was built because the gas for the Robston increased from 4.7 million per block to up to 9 billion per block. The entire network was blocked. Coven was introduced because Parity team found out that no, the community has to do something. Otherwise, the fake miners can easily adopt a test network, and they can do whatever they like. Coven was introduced to use a proof of authority other than proof of work. Authority means that if you are a reputable data center or you are a very well-known community member, you can verify the contracts without any computing power. So this is called proof of authority. Especially like in the US, other than it doesn't require the votes. And Rinkeby is the same. It's just make it more compatible with Gas, both client software, Gas and Parity. I'm telling this story because I want you to know that although many people believe that proof of work is the ultimate strategy for the blockchain industry, POW can sometimes be more vulnerable, especially when we don't have enough surplus for constantly we cannot provide enough surplus to those miners the miners can easily go against you, and they will abuse their power, and they can change the network without a consent of the community members. Okay, so here comes with the problem of a consensus. If POW, we cannot count on POW, what else do we have? We have a few alternative solutions. Let's go for BFT. The problem for BFT is that BFT is somehow quite centralized because physically it cannot support more than 100 nodes. IBM has tried that. The Hyperledger cannot support over 100 nodes. The BFT, DBFT, for Neo and for EOS, they only support 21 nodes. That's not decentralized enough. It's against the decentralization. Although some people think that 21 is enough. Why do we need more than 21 nodes? Still, a lot of people believe that 21 is not enough. Because if I accidentally control like 11 of them, well, 11 is not enough. If I ever have access to like 15 of them, I can DDoS 15 of them, then I can block the entire network. Yeah, that gives the for bootstrap stage or early stage solution. That's only one left. It's POS or the DPoS. DPoS is like POS. And people vote, it's like a proof of authority. You don't have to prove that you have enough computing power. You just need to be elected. You just need to be trusted. But then another problem is that the DPoS nodes can be corrupted. Sometimes you can refuse to pack some contracts or some transactions. So there's no perfect, flawless solution for a good consensus mechanism. But I would suggest that first, when you're at early stage of a public test network, DPoS might be your best choice. Some people ask me, how are you going to compare with the IoT? IoT is using DAG. But remember that DAG is not a consensus mechanism. DAG is just the structure of the data. It's an alternative solution to blockchain. However, IoT is using a centralized coordinator to synchronize all the status between all the nodes to make sure that the entire network is up to date. So it's a centralized coordinator, and it's not going to change within like 2 or 3 years. So the flawless solution is not yet to be built right now. So for consensus issues, I would say that in the next year or 2, you're going to see more DPoS-based public test network, including for IoT-based verticals like Ruff. Ruff is using DPoS for sure. And the next question, other than consensus pain, is the scalability. A lot of people, when they are the first thing in their white paper is that they clearly identifies that the current problem for Ethereum is that it can only support 20 TPS. It can be easily jammed by CryptoKitties. And if we're talking about the Internet of Things, we're talking about billions, minimum, billions of devices. It's even more than the cell phones, more than the PCs, more than the population on this planet. And in order to support transactions between all the devices, you cannot use like 20 TPS, 20 transactions per second. You may have complicated contracts, and you may have lots of transactions happening at the same time. And the Lightning Network, that's centralized. That's part of centralized, whatever. It's not the best solution. So right now, 3 mainstream solutions will be sharding, clustering, and optimization itself. I'm going to start from the right to the left side. Optimization means, for example, the sequential read and writes. LevelDB can read writes relatively fast. But in order to chase to the most up-to-date version, Ethereum is struggling because the tree, the global status of all the contracts is going to be 500 gigabytes already 500 gigabytes, and it's growing. It can easily go up to 1 TB. That's huge. And we need a faster way not only to do the sequential read and write, but also you can do the random read and writes. Sometimes you have to find the key and value pairs in the purchaser tree, and you need a better way, a faster way to find the value and store the value or change the value. And it make it easier for other people to read that. And our SSD may not support that much, and if you put everything to memory, it's not persistent. So optimization could be a lot of companies are doing this. So optimization would be a major topic within next year. It's going to be hot. Luckily, we're standing on the cutting edge of this technology, and we managed to bypass level DB, and we can increase the sequential read and writing even 5 times faster than the current public chains like SSD, Redis, or something else. And for sharding and clustering, sharding is an old-school approach. It's like dividing the entire network into subsets. And you just merge. For example, if it's transaction-based, it's UTXO. Transaction-based, you can easily divide your unverified transactions with like 50 or 100 subnets and let them, using their consensus mechanism, to verify, to pack all those transactions at the same time, and then you just merge them. But transactions, UTXO, means that order doesn't matter. But for contracts, like Ethereum contracts, we're facing dependency issues. What's dependency? Let me give you an example of dependency issue. You might want to execute one part of your contract, but this part of a contract may take the other part of a contract as a prerequisite. So you either put them in all together in a single thread, or you have to find a way to merge them, because you cannot execute them. You cannot do the parallel execution at the same time. So sharding is facing this. So Zilliqa is doing a great job on the transactions, but for contracts, it's still a long time to go. Luckily for us, we managed to find a way to resolve the conflicts. We cannot say we can resolve 100% of the problem. Sometimes, if it's too much atomic operations and related to the exchanges, I still have to put them into a single thread. But 90% of the chance we can manage to do the parallel computing. So scalability issue will be solved by within 2 years, and there will be a lot of enterprise level public blockchain, which is still at the early age, which could be a pretty good investment. Yeah, that's the. I think I got the wrong slide. Still the sharding clustering optimization. I'm going to skip that. I'm going to skip that slide. And the next thing is, I think the most important part for Ruff, other than I'm not talking about ADA, I'm not talking about the NEO, I'm not talking about quantum, nothing else. The most special part of the technology is not technology itself. It's about how you design your application interface, which means you have to make it dev-friendly. If we're talking about the Internet of Things, we're not talking about the PCs, which are almost identical to each other, or the cell phones. The cell phones are pretty much the same. The cameras, the screens, GPS, they have the same components. But if we're talking about IoT, we're talking about cameras, sensors. They can be different models, different drivers, different protocols. There's nothing like Android in IoT, because there's no unified abstraction for those hardwares. So dev-friendly becomes a major topic. I realized that in 2014, it's been 4 years, and I've been trying our best to make it easier for the developers. You may see some developers, they are good in developing web-based UI, but they cannot develop the IoT, or I would say the embedded system development, like develop the smart car, smart home, whatever, because they are facing the edge computing issues. The edge computing includes C code, memory controls, process management, all these kind of things. Let me show you the code. Code is a law. I like the word code is a law. On the left side is the traditional old school approach to build a embedded system application. You have to write with the GPIO, general protocol stuff. You have to figure out how the memory works, memory structure works. You have to find out, if you have to do the driver porting to different platforms, like from TI to MTK. But on the right side, this is what Ruff did. We not only will support you with JavaScript runtime on could be embedded devices, we also have an abstraction for you to write program directly towards those devices and toward those objects. And you can easily upload your data to the cloud side or on the blockchain. Because if the blockchain needs to store the data, it has to be in a single format. It cannot be like, okay, this is this model, this type, this driver, and this is the instruction I get in return. If other people is reading it, they have to find the text specs for manual text specs for that particular device. This is not going to work, especially for the Internet of Things. Once we get a chance to connect everything and make it dev-friendly, we can find out that we enabled a newer internet. It's not the PC-based or a mobile-based network, which interface matters. In our network, like shared bicycles or Airbnb or the logs or anything you can imagine that, or the power plants, anything you can imagine of. It's so-called a new network. There's no screen for that. There's no user interface for that. All you need to do is that you make a payment and you get utilities. You get the values from somebody else. It's like vending machines. Actually, you don't need a screen for the vending machine. All you need is just you insert the coin into the slots, or you just scan the QR code. Well, that was the old school approach. You scan the QR code, and you make the payment, and then you get your Coke. And this is the so-called value network, which is not that visible. We can feel it, but we don't interact too much by the interface. It's not the regular information network. So it's like a 99% to 1. The reason why I'm calling is that most of your time you're glued to your cell phones. Believe me, everybody's glued to your cell phones. If you ever have a chance to count how much time you use your cell phone, it's probably like 10 hours a day, 12 hours a day. That's fine. But other than that, all your value-based transaction, like your shopping, like your renting or leasing or investment, they're supposed to be like take 99% of your savings or of your assets, but not just for. But there's only 1% is for display. It's through the interface, user interface. So it's completely different. And in order to enable that, we do need to make it more dev-friendly. Back on that part, we have to use something like that on the right side. We have to enable all the developers who are not the technical experts, who are just the ordinary people. You may have a bachelor degree or even less, or you just are trained for like half a year, 6 to 12 months, and you're supposed to write something like that. If we can enable more and more developers, not just for the top-tier developers, just for random ordinary developers, we're going to see that we're going to enable a bigger world, just like Ethereum. The beauty of Ethereum is that it's so easy to use. And if anyone can make it easy as Ethereum, or it's even easier to enable the developers in any ecosystem, you're going to change the world, definitely. And I'm going to show you a user case of a solar power panel. It's connected via our operating system called Ruff. This solar power plant needs roughly $1 million US, and it generates 1 million watts. And the yield is 16%. The return is relatively high. But how do you guarantee that we have the yield? We can monitor this, and we know that the cost of the maintenance and or the how good the asset is in order to divide them and sell to the people from general public to make it asset-backed security. We need blockchain. We need to make sure those data are legitimate. You cannot tamper. You can tamper a single device, but then you will find out it's not. There's a contradiction between the data with the other either and the other side of data. So we will make sure it's using our synchronization technology. We're going to enable people like this. Those people, they develop the applications like this, and they are able to sell asset-backed securities. This is one major user case. Yeah, I believe many people like blockchain for different reasons. I understand all of them. But for us, for Ruff, for myself, I believe that the future belongs to developers. Only developers can change the world, not investors, not the miners, whether you like it or not. Thank you. Feel free to contact me if you have any questions. And I have my WeChats, our Telegram, our everything. Facebook. Okay, thank you.
Thank you so much for your sharing, Mr. Riley.